Hi everyone, welcome to this video on Enum and Swift. Now enums are pretty straightforward to understand. Enums are basically what the definition says is that enums are a user-defined group of related values in a type-safe way. Now what we will do, we'll break down this definition into three parts. First is the user-defined, second is the group of related values, and the third is type-safe way. Now, how we will understand this is when we think of numbers, we have a predefined user type integer. So what we do is we create a variable and give it a type integer that is int and assign it a number 1, 2, 3 like that. So for numbers, we have a type int. For words, sentences, we have a type string. But have you wondered when we think of something totally random that is, let's say, directions? We think of east, west, north, south. We don't have a type for this. We don't have a type to give it to a variable, and then we can store these values. Hence, this is where enums comes into picture. Why enum? This is something that we are enumerating. This is something user is defining. We are thinking about these values, and hence the term enumeration and the keyword enum. So what we do is we create this group of related values and we call them direction, and the direction becomes the type. We call it enum. Also, we'll go into the types of enum, that is enum with raw values and enum with associated type and also named associated type. We will get onto the protocols, what all protocols that goes along with enums and how it helps us. Then we will look into the combination of enums with protocols, how it goes along with in when it is combined with types of enum, that is enum with raw values and enum with associated values. So after that, we will also look into the real world examples. So we are going pretty deep into what enums is. So grab your Xcode and let's get started. Let's jump into the code and start understanding by the definition. So now let's see the definition and understand what the definition really means here. I will write the definition here for reference. So we will break this definition into three parts: user defined, then group of related values, and type safe way. Now, as we were discussing on if we have values, number values, there is 1, 2, 3, we have an integer type that we can give to a variable just like that, and we can store that value. And when we have a string, something like this, we have the string type to give it to the variable, and we can store this value. But when we talk about something random like east, west, north, south, these are set of values which are related. So it's a group of related values. Now, this is something which is user defined. This is something that we have enumerated, we were thinking of. And what we can do is we can wrap it and give it a name, direction. Now, if I want to create a variable here and assign a value east, now I don't have a type here to mention. Why? Because this is user defined and we don't have a type for this. We don't have a type, like for example, for like we have integer for numbers, we have string for sentence and words, but for this user defined type we don't have a type. So this is something that we have enumerated. That's why the term enum we can mention it here. And to give the values to the enum, we have to use a keyword called case for all the values. Now we have our enum ready. What we can do is just copy and give that as a type here, and I can use the values to store it in the value in the variable, but I have to use a dot notation, and that's it. That is what the definition says when we talk about user defined group of related values. Now what do you mean by type safe way? If I were to give here something else, something totally random, east north, it won't take it. It will give you a compile time error, and that is all what type safe really means. If I will try printing the value third after giving it a correct value, let's run it. Now let's try to give it some other value, run it. It will return us runtime error. So that is what type safe really means. Now, as we know something about enum, we can now jump to the types of enum, that is enum with raw values and enums with associated type, and also with named associated type. Now, when we talk about the types of enum, the first one is enum with raw value. I will take this enum and paste it here. I will comment the whole code from here. Now what raw value really means is that if I want to give it some predefined value, let's say E for east and W and like that. So to mention the values, we call this raw values, and we have to mention the raw value type here. And that is it. That is what raw value really means. I will give this also a value, and here I will print direction dot north, and it will print north. And if I add raw value keyword, it will give me the raw value. And if I change it to south, it should give me S. And that is what all enum with raw value really means. Now we can take a look at the associated type. That is the second type. So this is the first type. Now I will create an example enum laptop. It will have a name, and that name can have an additional value. We can pass some additional information. All I have to mention is the type here. Now, if I want to create a variable and call this, and if I will use it, let's run it. It will give me the case along with the associated value with it. Now, this is all what enum with associated type is about. Now, to make it more sensible, we can give it a name also here. Something like this. and I can use it while I'm giving the value. Let's run it, and that's it. This becomes named associated type because the associated type not only has the type but also a sensible name attached to it. So we have seen enums with associated type. So I will say we have seen enum with associated type, and also we have seen enum with named associated type. Now let's look at the third point in our tutorial, that is we can add a method also inside an enum. Now to add a method, I will take an example of the direction and I will comment this part. I'll bring it here. I will create a variable here and give it a direction like this. And when I want to use like direction dot description, and I want to print the description for it. Now I'm not expecting the raw values, but instead I want, based on that value, I want a description. So I will add here description function. Now in here, based on the caller, that is the direction, based on that value to which I will call self, I will write a switch case. And for every value in the enum, I will write a case here. For north, I will add some string. And that's it. Now let's run it. So it works. Now that we know that what enums look like, what's its definition and the types of enum, that is the enum with raw values, enum with associated type, and also with associated named associated type. It's time for us to take a look at the protocols that enum can conform to. Why enum needs to conform to protocols depends on the use case of the protocol. For example, if you want to traverse through all the cases of enums, in that case, we need to make that enum conform to protocol called CaseIterable. Let's get started with the protocols. Now here I will create an enum and traverse through all its cases. I will use our already defined enum, which will be this one. I will remove the raw type we used. So we have a simple enum with us. Now, if we want to go through all the cases and traverse through that, let's make it conform to the case iterable protocol. Now, when we do direction dot all cases, it will give me all the list of all the values, and I can apply a for loop on it. Let's run it. Okay. I have to comment the above code. This code, and also I will comment this part. Now let's run it again, and we get all the values one by one. Now let's move on to the second protocol called rawRepresentable. Now this is a protocol that Enums conforms to by default. Let's take a look at that. So the first protocol we saw is CaseIterable, and second we'll take a look at rawRepresentable. Now I'll create an enum called pizza size, and it will have some raw value with it. The moment I have written here a raw value type, this enum automatically is following or conforming to the protocol rawRepresentable. We don't have to explicitly mention it. I can use some values and give it a default raw values. Let's run it, and it gives us the value. Now this doesn't look like conforming to a protocol rawRepresentable, but by just giving the raw value type, it automatically conforms to the protocol rawRepresentable. Now let's take a look at the third protocol called Equatable. This helps in checking if two values of the enums are equal or not. So the third will be Equatable. Let's take this enum. I will comment it from here. And what I can do is direction dot east equals to direction dot west. And I will just print it. I will remove this protocol. So it's a simple plain enum, two values we are comparing here. Let's see. It returns false. So Equatable is something that is again just like rawRepresentable. Enum by default conforms to the Equatable protocol as well. And now we can jump to the next protocol, that is Hashable. Now Hashable is a protocol that we use when we want to use the values of enum with dictionary as a key and in a set of values. Because the underlying implementation of dictionary and set is hashing, we have to make our user defined group of values conform to the protocol Hashable. Let's take a look at that. I will take the same enum. I will comment it from here. Now what I will do is create a set of direction. And I want to store values like north, east. I will name it direction set. Now that we are not facing any compilation error, that is because Hashable is again just like Equatable and rawRepresentable by default is confirmed by this enum. So we are free to store the values like that in a set. Just like set, we can define a dictionary here and we can use the values of enum as the key in that dictionary. Now let's move on to the next protocol called Codable that we use when we want to send the local data in the server. Now what we do with the local data is we convert that local data into a JSON format first, and then we send it in the backend to the server. This conversion is called encoding, and to encode our local data like enum, we need an encoder. And let's take a look at this example. I will take the same enum. Now, what I want to do is encode this data. But to encode this data, I have to make it conform to a protocol called Codable. And now I can create a encoder and encode this data or convert this data into a JSON format. So this is my encoder, and I will say encoder dot encode. And once this encoding is done, I want to store the converted data into a variable called JSON data, because this is the data in the format of JSON. Now we can name it JSON data. Now this encoding might fail, so I have to use a try keyword before it with a question mark. Now let's print it. Now if I'll print it straightforward like this, it will give me in bytes. It will say that it's an optional 12 bytes of data. So I have to use a string function here. And I have to mention a format here that I've used to encode that data. And let's print it. And this will say that we have the data, and this parenthesis will confirm that the data is now converted into a JSON format. Now that we know that for converting the local data into the JSON format, we have to make our local data conform to Codable. Now, what if we want to convert the JSON back into local data? In that case as well, we need to make our local data conform to Codable. This is something that we will take a look when we are making or learning how to make API calls and how to handle the responses. For now, we can move on to the next protocol, that is CustomStringConvertible. This is the protocol that we use to give some meaningful description to our cases. Also, the question arises here that the raw value that we were using with enum, that also gives some sort of description to each case. So we'll take a look at how it is different from how these two are basically different. So I will take the same enum, I will comment the whole code. Now instead of Codable, I will make it conform to CustomStringConvertible. Now if I will run this, it will give me an error asking for the direction does not conform to the protocol. So the error says that it is expecting a description of type string like this. So the moment you your enum conforms to the custom string convertible, you have to declare a description of type string here. Now this description is going to be a variable, and here we can give the description for each case based on its value. So I will say switch based on the value, that is self. Whenever we are making a call like direction.east.description, then it will consider the value direction.east as self, and it will check for the cases, and it will see the case east, and it will return east, and just like that the other cases. And that's it. Let's use it. So right now I don't have to, if I'll just print it, I don't have any raw values here, and I'm just using it. And if there were no description, then the print function will actually give me the not. But now, since I have a systematic meaningful description for each case, it will be taken as self, and because of the protocol, it will give me this value and gives me not. If I will make it capital. So what happens here is, if we don't have the description and we do not conform to the protocol, in that case it will give me not. Why is this here is because enums, as we have seen, it automatically conforms to the protocol raw representation, and that gives a default value to each case, which is equals to how they are spelled. So even though you have not explicitly mentioned here that I have the raw value for each case, it already has something like this, and hence you get not. So now we have seen why custom string convertible, what it does. Now we want to take a look at the question, that is, what is the difference between having a description like this and the raw value. I'm mentioning here the raw type and giving it a raw value. What is the core difference in between these two? So now let's take a look an example for that. I will uncomment this code and leave it as it is. Now here I will create an enum size and give it a raw value. And then I will take the same enum and give it a custom string convertible, and then we will see the difference. So the first key difference is the purpose, that is the enum values, which is these, the raw values, are used as constant and something that we can use in a internal logic or some sort of comparison. And when it comes to custom string convertibles, here we are using this string for giving a meaningful description to our case. And this is the second difference is the flexibility. Here these types are going to be fixed types. It has to be of the same type. that is the raw value type. But when it comes to custom string convertible, this can vary. Right now, you can see it's all string, but we can have a value here which will be taken from an associated type. Now, this is something that we will take a look in the upcoming section. That is, we have seen the enum types, and enum with protocols. When we will discuss enum with protocols working in combination with enum types, that's when we will actually understand this concept. But for now, just remember that the difference is this is flexible, this is dynamic. We can have a variable here, and that is something that we can capture here, x, and I can put it here. Now this is dependent on this associated enum value. I will also have to mention it here, x of type integer. To make this more sensible, I will write a different example here. Or status, which will conform to the custom string. Now, if you take a look at this example, this is very much similar to size, except after conforming to custom string convertible, we have these two cases, which is using associated type. Now, when we are giving some sort of description, let's say for shipped, we are saying your order is shipped on date. Now the date is something which is dynamic, and the description is varying based on the value, which is again something that we are expecting from the caller. Now when it comes to the enum with raw values, these values are going to be fixed, and it should be fixed in the sense the type will be fixed. A type should be the type of raw value. So far what we have understood is we have seen at what is enum by definition. We have taken a look at what is enum types, that is enum with raw values, enum with associated type, and also with associated named associated type. We also now looked at enum with protocols. Now I want to combine the enums with protocol with types of enum. So there are a few questions that comes in mind that we will tackle next. Now the first question that comes is, can I mention all the enum values in a single case? So the answer is yes, we can. For example, we had east, west, north, south. Instead of giving separate case keyword for that, we can give a single case and we can declare everything in one single line. But after this question, there are two more questions that comes to the mind in general. What happens to the raw values and associated type and associated named type? Can we use that with the cases still? So the answers to both of the question is yes. Let's take a look. So if I mention the first type of enum, that is the raw value, enum with raw value. So I will mention a raw value string here and give some string, and let's try calling it, and we'll print it. Let's run it. So it says previously declared, so I need to comment the above code from here. Let's run it. So we have redeclared size. I think I need to comment this code as well. Let's run it now. And it gives us west. Now if I add dot raw value, it should give us W, and it gives us W. So it works. Now the second type, that is the associated type, or named associated type. So let's remove this raw value type from here and the raw value as well, and give associate type integer. And when I'm calling it, I will give it a value like this. Let's run it. So it gives me like that. And this is associated type. And let's check for named associated type as well. I will make it more sensible and call it kilometers, and give it like this, and it works. So now that we know that enums can be declared in a single case as well, but the best practice would be to use them in a separate case. Now let's take a look at one more question that generally everyone has, that is, can enum conform to the protocols? Since we have seen protocols, what about, can we still have the raw or the associated values? So the answer to that, yes, we can, but the clubbing should make sense, or should be sensible. What it means is that when we are making our enum conforming to a protocol, for example, CaseIterable, let's take an example and understand this. So we have the direction case. So here is a enum that is conforming to a protocol CaseIterable. Now let's see if we can still use raw values or associated values with it. The very first thing to note here is that when a enum conforms to a protocol like CaseIterable, it can use, or any other protocol, it can use any one type. One type means that you can now use either raw value or associated type value. So I will mention a raw value here, and I'll give it a raw value like this. And if I will run it, it will work. I will print all the cases. Let's run it. Okay, I need to comment this code. Let's run it again. And now it gives me all the values. But CaseIterable is the protocol that does not work with the second type, that is the associated type. So I will remove this. Now it throws an error. It says that direction does not conform to the protocol CaseIterable, and it says it requires a property all cases with type like this. If I will comment this part of the code, it will still say that the protocol requires property all cases with the type array of direction. So it means that if we cannot use all case keyword, it means the CaseIterable is not the protocol, is the protocol that direction is not conforming to at all. Why is this happening is because This adds a dynamic nature to Enum. When it comes to raw values, each one of the case will have a fixed type value, and hence the iteration is easier, iteration is possible. But because in associated type, this is the type which is only for one case and it's not for the rest of the cases, the iteration is not possible. Now, since we have seen about 5 to 6 protocols, let's talk about the rest of the protocols other than CaseIterable. When it comes to this question, let's go to the other protocols. So the answer to that question is yes, an enum can conform to a protocol while having a raw or associated values. However, the behavior is different. With raw values, it can conform to the protocol like rawRepresentable, which we have seen here. Now this is something automatically it can conform to, and then we can make it conform to another protocol like CaseIterable to iterate over the values, and also it can conform to Codable, and it will work all completely fine. But when it comes to the associated value, we can conform to the protocols like CustomStringConvertible and Codable as well, but we cannot make it conform to the CaseIterable protocol in that manner because it will not be iterable. Because in terms of associated values, that associated value could be only some of the cases can have the associated value. In that manner, we cannot iterate over the enum. Now, what I mean by saying all this is something that we will take a look with an help of example. So here I will create an enum name size. Now you can see this enum is conforming to the protocol rawRepresentable, as by default it does conform like this. And along with that protocol, we are having CaseIterable as well, and we can easily iterate over the cases like this. Let's run it. I will comment this part. It will give me all the values, and I will write one more example for associated type. I will create an APIResponse, and I will make it conform to a custom string convertible protocol. Now here we have an associated type and enum is conforming to the protocol. Now that we have data, um, it is of type string and this is type also string, but this is something that can vary. Maybe there is some more case that can come up, and that type, that associated value may have the type integer, let's say. So this is something that is not fixed and it can change. That's why the iteration is not possible, and we cannot add like case iterable here. That will be a false case. So we cannot do that. Let's print it as well. And it works. And that is all. When we look at this question, I hope you have the clarity on this question now. Thank you for watching this video on Enum in Swift. I hope you have understood the concepts. what we have learned in this video is the first thing we saw is the enum definition, then we jumped onto the types of enum, that is enum with raw values, and the second type enum with associated type or named associated type. Then we took a look at the protocols. Before that, we looked at we can declare methods in enum as well, and then we jumped onto the protocols, what all protocols are there and why enum needs protocol. For example, in CaseIterable is a protocol we can use to iterate over the cases. Then we jumped onto we looked at about five to six protocols that enum can confirm to. Now this is just to give you an understanding on how enum can actually confirm to a protocol as well, and later when we will take a look at production level code in the further videos, we will get a chance to understand how enum and what all other protocols enum can confirm to. Now that we have seen enum with protocols, we had some questions, that is what happens to the enum types, that is enum with raw type and enum with associated type or named associated type. What happens when enum is confirming to a protocol? Can we give some raw value as well or not? And can we still give the associated type or not? So we looked at this major question that usually everybody has, and we tackled some of the extra questions as well, that is, can you mention the cases in a single line? And the answer to that is yes. And can we give the raw values and the associated type in that case? The answer is yes to both of them as well. So that was the summary on all the things that we have learned so far. Now, finally, we can start going and looking onto the application, the real world application of the enums. But first of all, congratulations to you that you know so much about enum so far that now we can finally get on to the real world examples. Now, enums are used so much when it comes to API calling. We handle the responses using enums. And when it comes to UI development, game development, and one of the most common and the popular one, that is when it comes to error handling, we use enums a lot. So let's get started with it. So we'll start with the very first example, that would be for API calling, how enum can be used for handling the response that we receive in the API. Now, I'm not going to make a real API call, rather I will simulate the API call. So I will write code for that. Let's get started with it. I'll start with writing an enum of type API response, and I will comment this above code. So when I will make the API call, the response, the API call would be either successful or it will be a failure. If it's a success, then I will receive a data with it. So I will create an associated enum here. And if it's a failure, then I'll receive an error message. So for that also, I'm creating an associated, named associated type here. And there will be a third case, that is loading. Now this will be the case when the API call is still ongoing and we have not received the data or the failure response yet. And I'm adding progress, that would be of type integer. That basically means that how much of the API call is done, that is it done 50%, 40%, what percentage is done, and how much we have to wait really. I will write a function to create or simulate the API call here. Now here I'm using a completion handler since I'm going to make the API call or simulate the API call using an asynchronous call, and hence we need a completion handler for that. I will put a comment here stating and inside this asynchronous call what I'm going to do is start sending the signal that it's loading right now, and we are not done with the API call. So what I just did here is as soon as the execution of this function starts, this asynchronous call will start and we are calling a completion handler and giving it an API response that is an enum. Now to give the enum value, I'm using the dot notation and the loading case, and I'm passing a value to the associated type name here. Now I will introduce a delay of 2 seconds here, and then I will call the completion handler again and pass a value that is success. Along with that, I will also pass the associated named associated, that is data here. I will pass this some data of type JSON. Now I forgot to mention here the whole signature, that is I have to mention void, so that becomes the input type and that is the output type. Now I will write a function to handle this API call. Now based on the response I will receive, it would either be loading, success, or failure. So for the first, what we will receive is when we are calling completion handler here, we are receiving loading, and based on that, I will print the progress that we are receiving along with it. Now to receive the value progress, or when it comes to the success case, I will receive a data here. To receive it, I will have to create a variable here, that is data. And similarly, I will write a case for loading and failure as well. And I'll put a percentage sign here so that we will say the 50% is already done, and then it will take 2 seconds here and it will send the completion with the data. Now all I have to do is to call our API call function. So copy this, paste here, and response, and I will call here my handler and give it the response. Now I will give an external variable here so that I don't have to use it here. So to take a quick walkthrough on what we just did, so this is the API, this is the response enum where we have three cases, and in the handler we are handling the response for which we are receiving API response type here, and we based on that we are printing the data, error or progress. Now when it comes to this function, this is the asynchronous call that we are making, and to call a completion handler we have to mark it as escaping, because what escaping does here is that for asynchronous call is something that is running in the backend, in the background, and when it calls the completion handler here, it is something that is happening after the whole execution of the function. Now this is something that we will look more in detail when it comes to the concurrency playlist. So just know that this is enough for us to understand how enum is playing a role here in this example. And what we are sending here is the value loading. Along with that, to the associated variable, we are passing the value that is progress. So this here will have the value, and when we are making when we are using this completion here, we call a handler, a function, and we pass our response to it, and based on that response we can understand that either it will be a success, failure or loading case. If it's a success, to catch the data we have to create a variable here so that whatever the associated value that was passed, that will come to us in this variable, and we can just print it. Now we can run it. Now it says loading 50%, and after 2 seconds it is saying data received, and it has the JSON data inside which it has a key and value. That is something that we mentioned here. So what happened here is first this got executed and then this got executed. When it comes to this part, it gave us the progress, that is 50%, and called the completion handler, and the completion handler was given to this uh, came here, and the response was given to the handler, and handler took that response and it was a loading value in it, so it took the progress and gave us this print. Now when it comes to this one, it introduced the delay of 2 seconds, and after that again the completion handler was called and the success was given. The success is the value along with the associated data, that is JSON, and again it was appearing here and we pass it to our handler response function. So this handler actually understood that the response has dot success in it, so we catched the associated value in our variable data and we printed it. Now we can start looking on to the second example, that is when it comes to UI development, we use enums, and how basically we use enum to handle the view states. Now, the second real world example that we will see when it comes to UI development. So the view states is something that we can handle using enums. So let's get started. What I will do is I will create an enum here with the name view state, and again loading content with the data in it and error with a message. So what's happening here is that this enum will help us in managing different state of the user interface, such as loading, error, or the displaying of the content. Now what I will do is create a function called update UI here, which will be of type view state. And I will have a switch case here that would be based on the state. Now the state could be loading. In that way, what I will say, I will just show some sort of UI, which is more of a speaking about that the content is still loading. So maybe a progress bar. I'm not writing a code for displaying a view. Let's write a simple print function here. Now, if we have received the content, I will capture that in a in a in a variable here, and then I can showcase that content. But again, I'll just print it as of now. And in terms of error, if there is a message, I will just print that error. Now I will make a call. And then I will call update UI with this state. So instead of this line, there could be a lot more logic that can go. And after that logic runs, we have some response, and we can just pass that response, that is view state type response, to our update UI function. Based on the response, we can showcase either a spinner if the state is loading, and if we have the data, then we will showcase that data, and if it's an error, we'll display that error with maybe a pop-up box, something like that UI. And that's how we handle uh, the the view states. Now we can take a look at the next example, that is when it comes to developing a game. There are states related to the game. For example, the game is playing and the game is over, so there is a score that we display on the UI, things like that. So let's get started with that. I will mention here, and here I will mention So again, here I'll create an enum called game state. Now if the person is playing the game is ongoing. It means the state is playing. So at what level the person is something that we can add the additional information here with the case. In terms of when the game is paused, we have the state for that. But when the game is over, there is always a score that we want to display. And now I'll create the handler for that. And that's it. The handler will handle the state. I can make a call here. I have to create a state, or I will call it current game state. And then I'll say game state dot playing with level 3 handle response. Now it should be this one, and it will ask for the state, and that's it. We can run it now. Let's run it. So it says game is in progress at level 3, and we received the data from the previous example after 2 seconds. So I will comment this and rerun it once again. That's it. Now this is something I've not commented actually. I should comment this example. And let's run it now. That's it. Game is in progress at level 3. And now let's move on to the fourth example, the fourth real world example, that is exception error handling. So what error handling is related to enums, we'll see that. Now let's take a look at the fourth example, the fourth real world usage of enums, that is error handling. So sometimes when you make API calls, we want to handle the errors, and the errors are custom defined in the sense they are user defined. For example, we are looking for a file on an FTP server, and in return when we receive a response, they are sometimes like the file not found, or you do not have access to the file, or sometimes some unknown error. So what we are going to do is create and custom or user defined, that is something that we are going to define enum, and then we will use it. Let's get into this. So I'll write here error handling, and I'll create a enum file error, and it will confirm to the type error, not found. And we'll have an associated enum name here, file name, that is string. Access denied is the another one, and we'll again have an associated name here. So now what we are going to do is create a handler for this. And based on the error, that is the error, it could be not found. In that case, I will take the associated value, that is file name. And here I can write a logic that the file is not found. So maybe I can update a UI or something. Or for now, I'm just going to print the error message. For the second case, when we have received the response from the backend, but the file that we requested to look into is something we don't have the access to. So we'll receive the access denied as a response, and I will take the file name in the associated variable name here, and I'll just print it. Now here we can run some different logic, maybe something related to gaining access to the file or requesting access to the file. But for now, I'm just printing a statement. And that's it. Now we can call it. I will create an error type here. And I will give it to the handler. Yeah. And that's it. Let's make a call. And it says access denied to the file personal.zip. And that is it. These are the 4 real world examples that will help you understand how enums are used in real world activities. Thank you for watching this video on enums. If you have watched this video till the end, congratulations. And if you want to get more into enums understanding, keep practicing, and let's connect in the next video.